afternoon, Chris Douglas, Hillsborough County Fire Rescue, Station 38A shift, driver engineer. In this evolution, I want to talk to you guys about hydrant operations. Not so much the basics, but getting into the driver mindset for our individuals that are currently driving or going through that acting driver process. So in this evolution, we're in the mindset of we're in a tank to pump operation on scene. Firefighters have deployed lines. There is water that's being applied to the fire scene. And as a driver engineer, we need to understand, do we have a hydrant that is close enough for hand jacking application? Or are we gonna have that second due engine per SOPs catching a fire hydrant for us and bringing us large diameter hose on scene? Just a quick reminder, with hydrant operations, we have our 4.5-inch cap, which will be for our 5-inch, and we have our two side 2.5-inch caps, which will for us be for our 3-inch hose. So as a driver engineer, whether we're hand jacking a line or our second due engine is catching an external water source for us, the driver engineer wants to take their 5-inch section, connect it to their piston intake. We call for water. Water is established, sent to our apparatus to the piston intake. At that time, it is going to be extremely important that the bleeder valve is opened so we can purge all of the air that is in that line from that large diameter hose. Once that air is purged, at that time, we can open our piston intake fully, which we do that manually, and we can also see it visually on top of the Revolution piston intake. Once that water has been established into the truck, we are going to hear a change in the RPMs of the truck. There is a pressure relief valve that is built in, not only to the piston intake, but also the TPG as well. So you will not only see changes, but you will hear changes in the pump itself. At that time, once we have established that external water source by whichever means possible, it's going to be the driver engineer coming back up to the pump panel. Once they have introduced that water into the system, we are of the mindset that we are working on an external source. So at this time, you will notice the driver engineer will go to the pump panel. They will close their tank to pump. They will have a reading on their master intake of how much that hydrant is supplying them with PSI. Also at that time, if we're down to a half a tank from initial tank to pump operations, it will be critical for that driver engineer to crack their tank fill, not fully open it, but crack the tank fill to allow our tank to slowly fill up with water, which at that point, once we are full, our tank is full, we close our tank fill, so we always have 750 gallons in reserve in case we have a hydrant go inoperable, we have somebody run over fire hose on scene, a burst section, there is always a backup plan on that scene. So at that time, we're going to monitor our master intake valve. IFSTA always recommends that we don't go under 20 PSI of vacuum pressure. This given hydrant that we're using in this evolution, you can see we start with a static pressure of about 50 PSI. Just a quick reminder for the HCFR pump chart, we have red, orange, green, blue, and silver hydrants. This typical hydrant here is labeled blue, so we're expecting anywhere from 1,500 to 2,000 GPMs. A rule of thumb that I typically use is I stay on the lower side of gallons per minute for that typical painted hydrant that we see here in Hillsborough County. Once that driver engineer has established that external water source with that 5-inch diameter hose, at that point, if needed, if we are close enough to that water source, we can maximize a hydrant. When we use the term maximize a hydrant, at that point, we want to have 3-inch lines running off each ear of the hydrant, and we're going to attach them. We have one on the driver's side and one on the captain's side. We have 2.5-inch intakes that can receive that 3-inch hose, so we can, using the terminology, maximize the hydrant. This isn't going to be an evolution where you're going to see a change of 20, 30, 40 PSI in pressure. Typically on most blue top hydrants, you will see anywhere from 5 to 10 PSI increase for maximizing the hydrant. Don't forget, in the driver engineer section, you do have a 50-foot section of 5-inch, also 3-inch. and you also have a 25-foot section of 5-inch and 3-inch. And also every other truck that is coming on scene should be carrying the same complement of hoses when it comes to pony sections. At that time, when we're maximizing the hydrant, we've connected to our intakes. The driver engineer is going to go back up on the pump panel, not only make sure that their tank fill is initiated, but also we have to manually open both intake valves. At that point, once both intake valves are open and our 5-inch on our Revolution piston intake is open, we are using that term of maximizing that hydrant. We are trying to receive the max amount of water that can be delivered from any given fire hydrant here in Hillsborough County. At that time, once everything is established, we have a full tank. We can close again our tank fill. Once our tank fill is closed, we will constantly operate off that external static water source throughout that entire fire scene and operation. Also at that point, keep in mind, once we have that fully established, we want to also make sure that we are controlling friction loss. So even on 5-inch and 3-inch hose where we don't see as much friction loss, we want to keep the kinks and the bends as minimal as possible at that time. So as a driver engineer, always be watching your hose placement, any changes on scene that are taking place where you can help improve friction loss and water capacity on scene. Keep in mind also, on all these emergency scenes, there will be times that you may be waiting for the fire investigator. You may be told that scene operations are going to begin to cease at that point. So make sure as a driver engineer that if you are going to leave that truck in pump gear, we either crack our recirculating valve or we have a discharge that is open to where we can apply a slow, steady stream of water to make sure that our pumps are not going to overheat on scene. If you're advised that the scene is going to be completely shut down, at that time it's going to be optimal to go ahead and put the truck completely out of pump gear. So taking it out of pump gear is as simple as the driver engineer steps back into the driver cab, takes their foot, applies it to the brake, and at this time the driver engineer is going to put the truck from drive, it's going to place right back into neutral. Once it's placed into neutral, you will see the decrease in RPMs. The screen on our Pierce Sabers will tell you it is no longer engaged. So you have multiple factors. You also have your green lights at the bottom that will also allow you to understand that it is no longer in pump mode. So we're going from pump to road mode with our transmission. So at that time, we're going to go from pump back up to neutral, 3 to 5 seconds, waiting, making sure our pump is responding. And then we're going to go back to the top into road mode. At this point, the truck understands through the transmission that it is allowed to be driven again because it is no longer in pump mode.